Hello my dear students from grade 6. How are you? I hope you are doing well. Welcome back to our new video lesson. Topic 14, Lesson 1, Solid Figures and Nets. My dear students, kindly pay your attention to the following instruction from the teacher. Instruction number 1. Study the video lesson very well. Instruction number 2. To complete your assignments as per the weekly plan, log into your account on pearsonrealize.com. Alright. Before going, dear students, bring out your textbook, copybook, pen or pencil, and highlighter pen. Thank you. Alright. Review questions, today. First review question, are you ready? Very good. The Student Council made a banner for the pep rally. The banner is in the shape of rhombus with the dimensions shown below. You have the following choices. A. 12 15.2 square meters. D. 16 square meters. Very good. The correct answer is, choice C, 15.2 square meters. Now, let's explain our answer. Area of the rhombus equals base times height. Equals 4 meters times 3.8 meters. Equals 15.2 square meters. So Now, our second review question is, in the computer club 45% of the members are 6th graders. If there are 18 6th graders in the computer club, what is the total number of members? Dear students, pause the video now, make the answer on your copybook carefully, and once you get the answer, come back to the video. What is your answer? Excellent. The total number of members is 40. Okay, who is going to explain our answer? Good. There are 18 6th graders in the computer club. It is 45% of the total number of members in the club. 45% equals 9/20. Remember that, 1 whole is 100%. So, divide 1 whole into 20 equal parts. I part equals, very good, 5%. 2 parts equals, 10%. 3 parts equals of division. We will get, 9 parts equals 45%. But, from the question, 45% is 18. So 9 parts equals 18. So, 1 part equals 18 divided by 9 equals 2, which is 5%. Very good. 4, which is, very good, 10%. 3 parts equals 6, 15%. Continue this pattern also. So 10 parts equals 20, which is, excellent, 50%. So, 100% equals, I really appreciate. So how many members in total are there? 40 members. Another way, using percent equation. Percent equals part 18 divided by whole times 100. 45 equals 18 divided by whole times 100. 45 times whole equals 18 times 100 times whole. 45 times whole equals 18 divided by whole times 100 times whole. 45 times whole equals 18 times 100. 45 times whole divided by 45 equals 18 times 100, divided by 45. 5. Whole equals 1800 divided by 45. Whole equals. Alright? Dear students, for more review questions, you need to log into your account on pearsonrealize.com. Take printout, try to find answers and keep the paper in your portfolio. Submit your work to the teacher later. Thank you. Okay my dear students, today our objective is at the end of this video lesson, you will be able to identify nets of solid figures. Again, you can identify nets of solid figures. Very Alright my dear students, now, we are properly on our lesson. Now, we have a question here, for which you should find the answer, and share your answer with me. Our question is: what would the unfolded and flat box of dog biscuits look like? Draw a diagram to represent the doggies biscuits box unfolded. Draw dotted lines where the box is folded and a solid outline around the outside of the figure. The side of each square on the grid below represents 1 inch. Again, what would the unfolded and flat box of dog biscuits look like? Draw a diagram to represent the doggies biscuits box unfolded. Draw dotted lines where the box is folded and a solid outline around the outside of the figure. The side of each square on the grid below represents 1 inch. You can model with math by using a diagram to represent a three-dimensional figure. You have drawn the diagram of the doggies biscuit box. Very good. You were in appropriate way on drawing the diagram. The box has the following dimensions. Base length, 16 inches. Base width 4 inches, and height, 12 inches. The box, one as an upper face and the other, as a lower face, which are identical rectangles, and 4 side faces, which are also rectangles but as two identical pairs. When you unfold the box, it should be in the form, exactly like a diagram at the right. I drew the diagram in means of drawing. Your diagram may be in another position, but all the diagrams that you all have drawn will be the same. Am I correct? Yay! All the diagrams for a particular solid will be the same. Okay, dear students, now let's describe how we could have drawn the diagram in different way. Actually, the answer is very clear. All of us have drawn diagrams with own ideas. Some diagrams seems like similar but others seem like different. But we understood that, when we put each the other, all will be matching, but we need to rotate it, up to it matches with all the other diagrams. Is it? Yay! Great. So the answer for our look back question is your own idea used to draw your diagram. If your diagram seems different than the diagram I showed in the previous slide, answer now. After you write your answer, get ready to watch a video that describes the question, how do you classify solids?
How do you classify solids? Think about this question during the lesson. A polyhedron is a three-dimensional figure made of flat polygon-shaped surfaces called faces. The line segment where two faces intersect is called an edge. The point where several edges meet is called a vertex. How can you classify a polyhedron? How many faces, vertices, and edges does this polyhedron have? The polyhedron has 6 faces, 12 edges, and 8 vertices. These are prisms. Prisms have polygonal faces. Prisms have 2 identical, parallel, polygon-shaped bases. They are named by the shape of their bases. These are pyramids. Pyramids have one base. The base of a pyramid is the face opposite the vertex where the triangular faces meet. A pyramid is named by the shape of its base. Pyramids have triangular faces. Both pyramids have several triangular faces. Why is only the second pyramid considered a triangular pyramid? A pyramid is named by the shape of its base. The base of the first pyramid is a square, so it is a square pyramid. The base of the second pyramid is a triangle, so it is a triangular pyramid. Now you know how you can classify solids.
All right, dear students. Now tell me the answer for this question. What attributes of a solid figure should you identify in order to classify it as a polyhedron? Very good. The solid figure must be three-dimensional. My dear students, kindly pay your attention to another example on page 709. A net is a plane figure pattern which, when folded, makes a solid. On the figure, on a front view, we can see only some faces. Top part face, front side face and right side face. How many faces are there for a rectangular prism? Good. 6 faces. Of these, 3 are seen. What are the other 3 faces? Very good. The other faces are bottom part face, back side face and left side face. So, this diagram is a net of a rectangular prism. Okay, students, now how you know how to identify a solid from its net. Also, you know how to draw a net for a particular solid. Very good. Now guided practice, first part, do you understand? Question number 1. Explain the difference between a vertex and edge. What is your answer? Very good. An edge is the line segment where 2 faces join, a vertex is the point where 3 or more edges join. Pyramid and a prism. Great. Prisms have 2 parallel bases, pyramids have 1. Now guided practice part 2, do you know how? Read the direction, in 3 and 4, identify each solid from its net. Okay, number 3, what is the answer, or now? Great. This net is for a triangular prism. Okay, dear students, independent practice now. Read the direction, in 5 to 7, identify each solid from its net. I will give you 2 minutes to find the answers of all questions from independent practice. Are you ready? Time's up. Stop writing. Now tell me your answers. First number 5, very good. Square pyramid. Number 6. Triangular pyramid, excellent. Before giving me the answer for number 7, let's watch a video.
These are all three-dimensional shapes. Some of them can be classified as polyhedrons. What is a polyhedron? Well, polyhedrons are made of flat polygon-shaped surfaces called faces. A cone does not have flat polygon-shaped faces, so it is not a polyhedron. A sphere is also not a polyhedron. But these shapes all have polygons for faces, so they are all polyhedron. Let's take a closer look at one of them. The line where two faces intersect is called an edge, and the point where several edges meet is called a vertex. We can also classify this polyhedron as a prism because its two bases are the same shape, same size, and parallel, and because its other faces are polygons. Since the shape of this prism's bases are triangles, it is called a triangular prism. Let's take a look at another polyhedron. This polyhedron also has edges and vertices, but it only has one base. This polyhedron is classified as a pyramid because it only has one base, and because its faces are polygons. Since the shape of the pyramid's base is a square, it is called a square pyramid. When a polyhedron is unfolded, so all its faces lay flat, this is called its net.
All right, dear students, now tell me the answer for number 7. Very good, this net is for a triangular prism. Next, let's solve some problems that involving solid figures. Let's open page 710 now. Are you ready? Very good. Okay, question number 1. The Swiss mathematician Leonhard Euler and the French mathematician René Descartes both discovered a pattern in the numbers of edges, faces of polyhedrons. Complete the table. Describe a pattern in the table. Very good. The number of edges is 2 less than the sum of the number. Let's solve a higher order problem now. Read the question, number 9. Write an equation that relates the number of edges to the number of faces and vertices. Repeat. Write an equation that relates the number of edges to the number of faces and vertices. Very good. Very good. F plus V, minus 2 equals E. Substitute the numbers for each variable and solve for V. 6 plus V, minus 2 equals 12. 6 plus V, minus 2 plus 2 equals 12 plus 2. 6 plus V equals 14. E equals 8. Great. So, the cube has 8. Okay, dear students, now tell me the answer for 11. Which prism can be made using the net shown at the right? Excellent. This net is for a rectangular prism. Let's move, question number 12, which is the last question today. Draw a net of a square pyramid that has a base that is 2 units long and the height of each triangular face is 5 units. Repeat. Draw a net of a square pyramid that has a base that is 2 units long and the height of each triangular face is 5 units. Have you drawn the net? Very Okay, dear students, we did it. It is the end of our today's lesson. I hope you understood all the facts we discussed in this video lesson. So, try to solve the questions on pages 711 and 712 of your math textbook. Thank you. So, until the next video.